Okay, so what we're going to do is look at families of cubic polynomials in the second half of this double. So when we determine a rule for a cubic polynomial, it's pretty similar to the way we do quadratics. To find the rule for a cubic function to fit given points, what we do is we choose the best form that matches the information contained within the question. Okay, so basically, if we've got dilations by a factor of a from the x-axis and it's an inflected cubic, we use this form. If it's been translated, then we use this form. If it's got x-intercepts, this form, we can also use the general form if we have to. Okay, so let's just have a look at a couple of cases. Cubic function has a 0 or an x-intercept at x is equal to 2 and a repeated linear factor at x is equal to -1. So -1 and 2. And it also passes through the point 1, 8. So when x is 1, the y value is 8. Right, so what's it going to look like? All right, so I think it's going to do something like this. Okay, wrong. It has a repeated linear factor at x is equal to -1. Okay, so notice how I can't kick the function up to there. Okay, so this is a good bit of maths that you're seeing me do here. So I'm coming down and I'm trying to get it to go through this point here and it's not going to, okay? And I think the only way I can get it to do this, Control Z, is to do a negative cubic, and it's going to come up and do something like that. So repeated linear factor there and there. So what I'm expecting to have happen is it's going to be a negative cubic. Right, now is the method that we're going to use to get it. So I'm going to say that there's this dilation factor that I don't know about. One of the factors is x take 2 squared, and that is not the repeated one, and a repeated linear factor at x plus 1 all squared. So when this would be solved, it would produce those x-intercept and the repeated linear factor, or the bounce. All right, so now let's find out what this a value is, because conveniently they've given us this point. 8 equals a -1, 2 squared. 8 equals a, what's that going to be? -4a. A equals -2. So as suspected, it is a negative cubic, and it should have come out like that, and it did come out like that. So what does it say? It also find the rule. So our rule is y equals -2 x take 2 x plus 1 squared. No need to expand that out. That's perfectly fine in that form. Okay, here's another one. Find the equation for this graph, and it looks like that's a stationary point, okay? But beware, okay? This may not be a stationary point of inflection, okay? It's just maybe a point of inflection, and that yields an interesting graph. You'll come up against one that has an inflection point that's not stationary later on in the year, okay? But we're going to assume that this is a SPOI, a stationary point of inflection. Right, so what do I know about it? Well, I know it's got a dilation factor, and I know that the standard inflected cubic, which looks like that, has been moved over 2 units, so x take 2 cubed, and that's gone to 3 units. 3 units. So it's gone across 3 units and up 2 units, plus 2. Okay, and conveniently they've given us what I presume is the y-intercept, which occurs when x is equal to 0, -25. Right, so let's slam -25 in for y, a -3 cubed plus 2. All right, now we've got -27 equals -27a. A is equal to 1. Therefore, our function is y equals x take 3 cubed plus 2. cubic function has the rule of the form f of x equals that, and it goes through that and that are on the graph of the function. Find a and b, classic simultaneous equations. So we're going to go 16 equals a 1 cubed is 1, x times b is b, so it's just going to be a plus b. Here's equation 1. Equation 2, 30 equals 8a, 2 cubed is 8, so that's 8a, and 2bx is plus 2b. There's equation 2. So to eliminate, what I'm going to do is eliminate b. To do that, I'm going to multiply this by 2. So that's 32 equals 2a plus 2b. Then I'm going to call this, I'm going to grab the name 1 and replace it with that one there. Now to eliminate, what I'm going to do is 1 take away 2. 30 removed from 32 is 2. Negative 6a, and so 2b remove 2b is 0. 2a take 8a is negative 6a. 32 take 30 is 2. Now, a is equal to 2 over negative 6. A is equal to negative a third. Alrighty, so let's pop that into this one here. 16 equals negative a third plus b. B equals 16 and a third. Don't know about you, but I just can't cop mixed fractions. They just look like sort of year 7. So 30, 48 on 3. Mind you, stuff up the conversion of that and give that as your answer, and you've just further engaged and lost the mark. So maybe I need to deal with my issues with mixed fractions. All right, how would I do that on the calculator? F of x equals ax cubed plus bx. Now what we're going to do is use the template. So f of 1 equals 16, f of 2 equals 30, a comma b. There you go. Stupid. Okay, so I did stuff up that conversion. Okay, so note that 3 times 16 is 48, plus 1 is 49. So lucky I did that on the calculator, because that would have been highly embarrassing. B equals 49 on 3, and I'm leaving that in the video as a lesson to you all to avoid further engagement, because, yep, I would have just lost a mark on an exam. All right. Let's go this. Is this the last one? No, not quite. Okay, determine the rule for the cubic function shown. Okay, so what do we know? We're presuming that it goes through negative 1 comma 0 and 2 comma 0, and it's got this point there. We're presuming that this is a bounce. And even though it kind of looks like it's a little bit to the left of negative 1, we're just going to presume it goes through these integer values. All right, so let's put what we know down. Y equals a, x plus 1, x take 2 squared. Okay, so note that that one there is the bounce, which produces the kind of double factor, if you want to think about it like that. Okay, so now let's sub 3(2). Okay, so a is equal to half, therefore our function is y equals a half, x plus 1, x take 2 squared. Okay, cubic function goes through these points. To find a linear rule, you need 2 points, a quadratic 3 points, a cubic 4 points. Not quite. Notice that you can get one using this form 3 points, okay, because you have 1, 2, 3 unknowns here. So that's not quite true. But yes, thank goodness, I've just scrolled down a bit further here. This is really a CAS question, okay? And so what we're going to do is we're going to say let f of x equal ax cubed plus bx squared plus cx plus d. Then we're going to say f of -3 equals -74, f of -2 equals -23, f of -1 equals -2, and f of 1 equals -2. Now, after we simultaneously solve that, we're going to get a equals, b equals, c equals, and d equals. All right, so let's set that up. So I'm just going over to my calculator and I'm going to define f of x equals ax cubed plus bx squared plus cx plus d. And let's get the template going. Oopsie. F of -3 equals -74. F of -2 equals -23. F of -1 equals -2. F of 1 equals -2 as well. Cool. So a equals 2, -3, -2, 1. Therefore, y equals 2ax cubed, take 3bx squared, take 2x plus 1. Whoops, that's wrong. Okay, so I've found what b is. B is -3. -3x squared, take 2x plus 1. Okay, so making a few mistakes today, but that's good. I don't really mind you seeing me self-correct those things. And note that if I've discovered what b is, that b gets removed from the general form here because I know what the value is now. All right, and these are from Mr. Tench's notes here, and he outlines a different method of doing it. I have to admit, I'm not a huge fan of this method, but I'm going to show it to you now. So what we're going to do is go to statistics. All right, let's hit statistics for the first time this year. Right, so what you basically do is put your coordinate points in. List 1 gets the x values, and list 2 gets the y values. So our coordinates were 1, -2. Well, that's that one there, is it? So is that the same one? Let's do this one here. -3, -74, -2, -23, -1, -2, and 1, -2. So let's run some regression on this. Okay, so what you do is you go to Calc, Regression, and what we want to do is a thing called cubic regression. What that essentially is going to do is imagine a cubic function drawn connecting up those 4 points, and it's going to get us one. It's going to get us a function that will go through all 4. So we go, all right, I want you to do cubic regression on this. Our x values are in list 1 and our y values are in list 2, so let's go OK. And it tells us that if the function is in this form, then the a value could be 2 or is 2, the b value is -3, blah, blah, blah. C value is -2, the d value is 1, just like we got by doing it with this method here. Now, the statistics method is probably a little on the quicker side, but what I tend to find, we put one of these on the Year 12 SAC last year, and the rule that came out actually came out with some clumsy fractions, like one of them was like an a value of, instead of being 2, it was like something ugly. It's like 23 on 7 or something like that. And students who use cubic regression on that ended up getting an approximate or using an approximation, because if we look at the fraction, like 23 on 7, came up like this, and students were like writing 3.2857, or worse still, choosing to round it to 2 decimal places and things like that. So that's the real weakness of the statistics method on that. So this is your go-to. This method here is absolutely the one that you want to use. All right, so homework is 6H, 1 to 7.